Hello everyone, welcome back to the ninth session of this IoT course. Last session I have demonstrated two projects. One is temperature and humidity monitoring in a room by using Arduino and DST11 sensor, and car parking system by using ultrasound sensor and Arduino. Today I will discuss what is NodeMCU and what is cloud, and then I will demonstrate how to build IoT application by using NodeMCU and a cloud ThingSpeak. Agenda of this session: introduction to NodeMCU and its usefulness, introduction to cloud services. I will discuss ThingSpeak cloud, then I will demonstrate IoT based temperature and humidity monitoring using NodeMCU and cloud service, say ThingSpeak. So now I will discuss what is MCU. MCU stands for microcontroller unit, which really means it is a computer on a single chip. A microcontroller contains one or more CPUs along with memory and programmable input-output peripherals. They are used to automate automobile engine control, implantable medical devices, remote controls, office machines, appliances, power tools, toys, etc. Now I will come to what is NodeMCU. Guys, you can see the picture of NodeMCU. The model name is NodeMCU Dev Kit 1.0. Developer ESP8266 open source community. Cost around $5, is very cheap. Operating system XTOS, that is a real-time operating system. CPU LX106, which is embedded within the ESP8266 Wi-Fi module. Memory 128 kilobyte, storage 4 megabyte, power USB. That means we can give power to this particular NodeMCU by using a USB cable. That means you can connect this USB cable to your laptop. NodeMCU is a low-cost open-source IoT platform and development kit that helps you to prototype or build IoT products. It includes firmware that runs on the ESP8266 Wi-Fi SoC, that is single on chip, and hardware which is based on the ESP12B module. The firmware uses the Lua scripting language, that is code is written in Lua language. It is based on the ELUA project and built on the ESP non-OS SDK for ESP8266. NodeMCU has two versions, version 0.9 and version 1.0. We are using version 1.0. So now what is ESP12B module? You can see, guys, the picture. The development board equips the ESP12B module containing ESP8266 chip having 32-bit LX106 RISC microprocessor, already I told you, which operates at 80 to 160 MHz adjustable clock frequency and supports RTOS. There is also 120K byte RAM and 4 MB flash memory where we can upload the program. Just enough to cope with the large strings that make up web pages. It supports JSON or XML data and everything we throw at IoT device nowadays. The ESP8266 integrates 802.11b or G or N ST40 Wi-Fi transceiver, so it can not only connect to Wi-Fi network and interact with the Ethernet, but it can also set up a network of its own, allowing other devices to connect directly to it. That means this chip has inbuilt Wi-Fi module through which you can connect to internet, as well as you can create your own network. This is the different power requirements. Power to the ESP8266 Node MCU is supplied via the onboard micro USB connector type B. You can also regulate 5-volt voltage source. The V-in pin can be used to directly supply current the ESP8266 and its peripherals. As the operating voltage range of ESP8266 is 3 volt to 3.6 volt, the board comes with a LDO, that is low dropout voltage regulator, to keep the voltage steady at 3.3 volt. It can reliably supply up to 600 milliampere, which should be more than enough when ESP8266 pulls as much as 80 milliampere during RF transmission. Guys, you can see the picture also. That is external power supply, then micro USB connector, you can see 3.3 output of regulator, then 3.3 LDO voltage regulator, 3.3 output regulator, 3.3 output regulator. So guys, you can see from the picture, there is a power requirement for ESP8266 or NodeMCU. Now the GPIO, general purpose input output. The ESP8266 Node MCU has total 17 GPIO pins. GPIO pins means general input output pins. So in this we have ADC, analog to digital converter channel, a 10-bit ADC channel, UART interface. ART interface is used to load ports serially. PWM pin is pulse width modulation output. PWM pins for dimming LEDs or controlling motors, because it gives variable analog voltage. SPI, I2C and I2S interface, SPI and I2C interface to hook up all sorts of sensors and peripherals. I2S interface, if you want to add sound to your project, you can connect through this interface. So guys, you can see the multiplex GPIO pins from the picture. Peripheral input output. The ESP8266 Node MCU features two buttons. One marked as RST, located on the top left corner, is the reset button and used of course to reset the ESP8266 chip. The other flash button on the bottom left corner is the download button, and it is used while upgrading firmware. The board also has LED indicator, which is user programmable and is connected to the DO pin, that is D0 pin of the board. It has inbuilt LED within this board. This is the USB to TTL converter CP2102. You can see the guy from the picture. The board includes CP2102 2102 ESP to UART bridge controller from Silicon Labs, which converts USB signal to serial and allow your computer to program and communicate with ESP8266 chip. This is the Pinout diagram. So already I told you this ESP8266 NodeMCU has 17 GPIO pins. Guys, you can see this is the different GPIO pins, right? And the 3.3 volt ground, guys, another 3.3 volt and ground. So next we have VIN where you can give input, ground, 3.3 volt ground. So this is the GPIO pins, guys. These are the reserved pins. This is the ADC 0, already I told you. This is the reset pin, right? This is the reset pin. Okay, this is the entire pinout diagram for NodeMCU. Advantages of NodeMCU over Arduino. The ESP8266 is a low-cost Wi-Fi enabled microchip with full TCP/IP stack and microcontroller capability. NodeMCU includes CPU core, faster Wi-Fi, more GPIOs, and supports Bluetooth 4.2 and low power Bluetooth. Additionally, the ESP32 comes with touch sensitive pins and built-in Hall effect sensor and temperature sensor. Very cheap as compared to Arduino Uno. And that is why whenever we are deciding that you want to build some IoT application, you can use this NodeMCU chip, or let's say you can use ESP8266. So now I'll come to the cloud, or you can say the cloud services. That is most important nowadays. Cloud computing is the delivery of computing services including servers, storage, databases, networking, storage, software, analytics, and intelligence over the internet to the foster innovation, flexible resources, and economies of scale. You typically pay only for cloud services you use, helping lower your operating system cost, run your infrastructure more effectively, and scale as your business needs change. So now I will tell you what are the services actually given by cloud. There are three basic services. One is called IaaS, that is infrastructure as service. That means we can use the cloud infrastructure like storage or CPU, server, whatever you want. Next is the platform as service. That means you can use the different platform like IoT platform or different platform where you can build your IoT application or any application what you want. Third one is the software as a service. That means you can use the software like, let's say in Oracle Live, you can use the Oracle Live Cloud and different software platform or software, whatever you can say. So that is the main thing. The importance of cloud computing with IoT. The cloud computing has entered the mainstream of information technology, providing scalability in delivery of enterprise applications and software as service. Already I told you. The IoT generates a vast amount of data that is basically called big data, and this in turn puts a huge strain on internet infrastructure. As a result, this forces companies to find solution to minimize the pressure and solve their problem of transferring large amount of data. Cloud computing and the IoT both serve to increase efficiency in everyday tasks, and both have complementary relationship. The IoT generates massive amount of data, and cloud computing provides a pathway for this data to travel. Application of cloud computing in IoT technologies. Cloud computing and Internet of Things are not very different technologies that are both already part of our life. Their adoption and use are expected to be more and more pervasive, making them important components of the future internet. A novel paradigm where cloud and IoT are merged together is forces as disruptive as an enable of a large number of applications scenarios. Some of the widely used commercial cloud services are Amazon Web Services, Cloud for RPA, ThingSpeak, Microsoft Azure, IBM Watson, etc. So we will discuss all these things. This include analytics services also. So now come to the problem statement of the project, that is temperature and humidity monitoring of a room by using NodeMCU and cloud services. We will be using ThingSpeak Cloud. Problem statement: temperature and humidity control is extremely important in modern industries, especially food industries, laboratory, pharmaceutical industries. Food safety law states that all food products have to be kept at designated temperature if they are going to be safe to eat. Having them too cold renders them inedible and too warm, and it could encourage bacteria growth. So it is essential to have a temperature monitor to protect the health of the consumers. We know excess humidity causes problems such as corrosion and IT equipment failure. Moreover, dryness of the skin directly affects several metabolic functions, including oxygen intake, the shedding of water vapor, salts, heat, and many more. So, it is very important to keep track of the temperature and humidity not only in offices and labs but also in your home. In this session, we use NodeMCU module with a DST11 sensor to send data to the cloud, here ThingSpeak, and perform some analytics on the data available. So now I'll state what is ThingSpeak, or you can say what is ThingSpeak IoT platform. First is what we can do by using ThingSpeak. Analytics IoT platform. Collect data from sensors, that is things. Visualize data instantly, has more than 60,000 users. Analyze data. MATLAB integration allows users to run scheduled code on data coming into ThingSpeak. Act on data. For example, send a tweet when the temperature in your backyard reaches 32 degrees. For example, that means you can also create alert or you can tweet. That means you can set the alarm. This is the picture of how it is working. That is, you can see guys, that you can send the data to the cloud, that is ThingSpeak Cloud, and in this ThingSpeak Cloud, analytics can be done, and the data is coming from the sensors, or you can see the microcontroller board or computer. So now guys, I'll show you how you can register in this ThingSpeak. So who uses ThingSpeak? Makers, academics, engineers, and scientists. This is the website, guys, thingspeak.com. just go to this ThingSpeak.com and register. First, what we have to do? First, we have to click on this link, or just type this link, that is ThingSpeak.com, in your browser URL bar, and then this screen will come, and just click on this button already highlighted over here. You can see, guys, in the picture, to create new account, click here. So now we will give your email, the valid email address. It is not necessary you have to give your organization email address. You can also give your personal email address. Then after that, so they will send you an email to your account. You have to verify this email, and then you have to fill up all these things, that is some credentials like email address, your location, first name, last name, and all these things. Then you have to press the continue button. This is the screen, that is the email verification screen. So now you have to set your password, and after setting your password, you just log into the account. That is, you have created one channel in this particular ThingSpeak, right? So just click on new channel, creating the channel. That means after that, after entering the password, that means we have created one account in ThingSpeak. Now we'll get this screen and click on new channel. After that, we will get this one. So we are actually implementing temperature and humidity monitoring of a room. So that is why. So first, give a channel name. You can see, guys, the name field. Then you can give any description of the channel. Then there is a field 1 and field 2. So in field 1 you give temperature, and field 2 you give humidity, right? Then just only save it. After that, we just click on save. Just go down and save. So after that, we will get this screen. Guys, you can see the screen. So here you can see the temperature and the humidity value in a graphical fashion. Now you go to API key tab and click on this tab. You will get this screen. This is the API key. You have to copy this API key and you have to paste it in your code, by which you can connect the NodeMCU and the ThingSpeak Cloud. This right API key helps to identify your channel. So now I'll show you, guys, so how to create an account in ThingSpeak and how to create a channel in ThingSpeak. Type ThingSpeak.com in your browser URL bar, then enter. Click on sign in, but you are not existing user, that's why you have to click on create one. Then give your email address. My case is Madri 2021 l@gmail.com. Then select location. My case is India. Then give first name and last name. Then continue. Then you have to select this checkbox. Use this email for my MathWorks account, and then continue. As soon as you press on continue, you will receive an email. So guys, you can see this is the verification email. Click on that and click on this verify email. As soon as click on this, you will get this screen. Your profile was verified. Now go to once again this screen and continue. And now you can set your password. I think you can see guys, this is fair first one. Okay, so that's why you have to accept this service agreement and then continue. And then your sign up successful, click on OK. So that's it. So this one, how are you planning to use ThingSpeak? So I think it is for our testing. So you can click on student use, or for my case is teaching. Okay. So I think guys, you can see this is the kind of a dashboard, right? So here there is a button called new channel. Now you can click on that to create a new channel. So what is our project? Temperature and humidity monitoring in a room. So that's why we have to give a name relevant to that. So you can write over here temp and humidity monitoring. Or you can give any name whatever you want. So here you can write we are using DST11, that's why I can write DST11 over here. But as per your requirement, you write the description about the project. So I am writing only DST11. So now you select the field. So in our case, first field is the temperature, second field is the humidity. Select this one. Next is humidity. Okay. So now just go down and then just click on save channel. As soon as click on save channel, you will get this channel dashboard. So where we have the channel ID, then you can see different tabs. Private view to display the data, public view to display the data, and channel settings, sharing, API keys. So we need this API key, right? API, click on that, because when I want to communicate with this NodeMCU and this ThingSpeak, I need this one, because by which the NodeMCU can identify this channel. Okay. I'll show you all the things when actually I'll start communicating with this NodeMCU and ThingSpeak, guys. So that is the way we can create the channel. Also, you can share this data or the link, whatever you want. So now I'll tell you how to prepare the Arduino IDE to work with the NodeMCU module. Go to Preferences from File, then copy this link into the field for additional boards manager URL. So guys, you can see the where you have to add the URL, this URL, okay, and then click OK. Then you select board manager from tools. Then search for ESP8266 board and select the version. For my case, it is version 2.1.0 and install. Then you can see that when you select tool menu, you will get both NodeMCU 1.0 ESP8266 12V module. Okay, so that is the thing. When you select this tool, and then you'll get a one drop down, and where you can select the NodeMCU board. You can see guys from the picture. I'll show you. Wait. Okay, so the board is selected. You can see, guys, the board is NodeMCU. Upload speed is this 15200 and frequency is 80 megahertz. So guys, this is the circuit diagram. So I have connected the data pin in D5 pin of this NodeMCU and ground to ground pin, and VCC, that is positive pin to 3.3 volt. This is the how you can connect your NodeMCU and your computer. Now I will introduce different components which are required to build the project. This is NodeMCU or ESP8266 module. This is a microcontroller board which has ESP8266 Wi-Fi SoC, that is single on chip. Within this module, there is a processor called LX106, which is a 32-bit RISC processor. Here, already I told you that this board has 17 GPIO pins. So these are the some GPIO pins. This is the port through which you can connect USB cable with this board and your computer or laptop. This is the antenna, that is 2.4 gigahertz. Antenna is embedded over here for connecting to your Wi-Fi. So now this is a DST11 sensor that senses temperature and the humidity. It has three pins. Positive, data pin and negative. Negative means ground, positive means 5 volt or 3 volt. So guys, you can see the wires. The orange one is connected to positive. That means you have to connect this orange wire to 3 volt of this NodeMCU board. Now this brown wire is connected to negative pin of this DST11, and you have to connect this brown wire to ground pin of this NodeMCU board, and the red one is connected to the data pin, and you have to connect this pin to D5 pin of this NodeMCU for this project. So this is the DST11 sensor. Now this is micro USB type B cable, USB cable, through which you can connect this NodeMCU board and the laptop or the computer where you write the code and where we have the Arduino IDE. And through this cable, you can upload the code from your computer to this board, or you can say the flash memory of this board. Now I'll assemble these components according to circuit diagram. First, I'll connect DST11 sensor to this board. So already I told you this orange pin is positive pin of DST11 sensor. So I'll connect this jumper wire 3 volt of this NodeMCU board. Then I'll connect the ground pin to this ground pin of NodeMCU board. Then after that I will connect the data pin, this middle one, you can see the red one, to D5 pin. This is the D5 pin. You can see from here also. This is D5 pin. Where I have connected, this is D5 pin. So then after that I will connect this micro USB to this port, and this part of this micro USB I will connect to my laptop. So this is the code. So I have used dst.h file, that is dst library, then ESP8266 Wi-Fi.h library, then Wi-Fi client library, and the ThingSpeak library. So already I told you I have used D5 pin for output pin for NodeMCU. So next I'll come to you can see guys, the SSID is my Wi-Fi username, or you can say the Wi-Fi SSID of mine, and then the password of mine. Then this is the channel number of mine, because this is not the channel what I have created just now. I'll change it when I'll execute the code. Then this is the write API key. Already I told you what is write API key. So this is the Wi-Fi connection code, and also I have written one serial.begin 15200. That means it is a communication between the serial monitor and the device, the serial port communication. So this is also the local IP, right? So code the serial.print Wi-Fi.local IP, that will print the local IP. And this is the function, the DST read temperature and DST read humidity, by which you can get the temperature and the humidity from the sensor or from the board, the NodeMCU board, and you can print also. And this is the two functions. These are the two functions that will actually connect your cloud, that is ThingSpeak cloud, and your the NodeMCU. So ThingSpeak write field, my channel number, that is the channel number of this channel. The field number one is the temperature, and the write API key, guys. And I just have inserted one delay for 16,000 milliseconds. The ThingSpeak will only accept updates every 15 seconds. So this is a snapshot I'll show you, please. Okay, so now I'll go to Arduino IDE. Okay, guys. So I'll show you that the preference. This is the preference. So here I have added this link. Already I told you, additional board manager URL. This is in JSON, and after that, in the tool, go to board manager. This is the board manager menu. From this board manager menu, you can see, guys, just type ESP8266 in the search menu, or you can just go down and search ESP8266. Please wait. As you can see, this is the ESP8266. Select the version. This is the version. You can select here, and just after selecting, the install button will live, and you can click on that. Okay. Currently I have installed all these things. That's why they are showing update or remove. Okay. Now you will select another library called ThingSpeak library. So guys, you can see this is the library. You have to install it. select the version and install. Guys, you can see the option that is installed, version 2.0.1 installed, guys. So now we'll select one more library, that is Wi-Fi client. Guys, you can see this is the Wi-Fi client. Select the version and install. Now, guys, you can see this is installed, the version 1.0.5. So now I'll go back to code once more. So now I'll go to this tools once again to select the board already selected. So still you can select because we are using NodeMCU 1.0 ESP12B module. You can select it once more, right? And this is the code, already I have explained this one for you guys. It's the same thing, but here I have used my SSID is this one and this one. But what I can do now, I'll change the channel ID and API keys, right? Just a minute. I'll go to channel and this is the channel ID, right? So the cell copy it first, then go to the program code and then I'll copy this one, Control V. That is the newly created channel, and then copy the right API key, guys. Go to this and click on this also. Copy. Then once again go to the program code and copy the right API key. Okay, guys, that is the thing. So already I have explained the code. Just a minute. I can also print this humidity value and the temperature value, guys, for you. Okay, so this is the button. First I'll select once again I go to tools, already I have selected, and select the port also, already selected, COM port number 7. Still I am selecting once more, and this is the button where if you click on this button, compilation and the uploading done simultaneously one after another. So click on that. You can see, guys, compilation and is going on. Compilation sketch. Please wait a minute. Still compilation going on. It will take some time. Compilation done, uploading is going on. Okay, So now you can click on the serial monitor. You can go from tools also, serial monitor, or you can click on that tab. Guys, you can see this is the temperature of my room now, and this is the humidity. Okay guys, the point to be noted, whenever you select this serial monitor, so just you can choose the baud rate from here guys. So for Arduino I have selected 9600, but here it is 115200. Select this one. Okay guys. Okay. So now I'll just show you something. This is my SSID of my Wi-Fi, and this is the password, and this is the channel ID already I have created. So these are some of the libraries already I have discussed. My data pin is connected to D5 pin, and also I told you the functionalities of these two functions and all. So now I'll go to ThingSpeak and check whether data is coming or not, or uploaded or not. I guess it is uploaded. As you can see, this is channel created 15 minutes ago, and data last entry less than a minute ago. Okay guys, now you can see the dashboard of this channel. So here you have the field one, that is temperature, and here you have the humidity. Guys, you can see the visualization. So here you can, if you click on that, you can see the temperature, date and time, and here also you can get the, in humidity also you can get the value and the time and date and all. Okay guys, just you can see it is increasing humidity bit 43 to 45. This is the way you can visualize the data which are coming from NodeMCU. Okay, just you can see once again drop in the humidity. Previously it was 45, but now it is comes to 44 once again. Okay, but in temperature you can see almost constant 28 degree. Okay, this is the visualization part of this ThingSpeak cloud. So now this is the private view, means because the data is not public, so you can also click on that. Same thing. So already I have discussed regarding the API key that you need this right API key for communication. So that's it. And also click on the channel settings. You can, already I told you that's how to create the channel. So you can give many more fields, right? But in this case we need only 2 fields. And you can click on sharing also. So keep the channel view private, so maybe it is public as per your requirements. So this is the most important thing, that if you want to use this data for doing any kind of analysis or any other purpose, you can download the CSV file. That means you have to click on data input export and just click on download. As you can see the values, but there may be some inconsistency due to some internet issue. Okay, but you are receiving this one, then you can use it accordingly. So this is all about Thank you.